Hello dear students, today I will discuss about system of linear equation, solution of linear system of equations. Okay, so also you know about solution of uh, system of equations by using inversion method, matrix inverse method, but uh, main thing is that how many unknowns are there, how many equations are there. So just consider the system of equations, linear equations, as a general equation. Suppose there are n equations and n in n unknowns. So we can write a1 first row, a11 x1, a12 x2, a1n xn equals to b1. Suppose this is first linear equation. We are considering in general form. Okay. So first equation is this. Just coefficients are naming by indexing a11, a12, a13 and a1n. N unknowns are there. Okay. Second equation, a21 x1, a22 x2, a2n xn equals to b2. And similarly, a31 x1, a32 x2 up to 3n xn equals to b3. And similarly, here counting 1, 2, 3 up to m equations. So we are writing here a m1 x1, x1, x2, x3, xn, n unknowns. So here am2 x2 and so on up to amn xn is equals to bm. Okay. System of m equations, 1, 2, 3, 4 up to m, and 1, 2, 3, 4 up to n. These are coefficients, n coefficients in first equation, in second, in third, and so n coefficients. They are naming by this. Okay, so this is system of m equation in n unknowns. System of m equations in n unknowns. Okay, this is system of m equations in n unknowns. it can be written in matrix form. A x equals to B. When matrix A is equals to m by n matrix A11, A12 up to A1n, A21, A22 up to A2n, AM1, M2 up to AMN. This is coefficient matrix. Okay, A. Where A equal to this coefficient matrix. Coefficient matrix. Coefficient matrix of this system A. Okay, and x equals to x1, x2, xn, n by 1 order matrix, and B equals to B1, B2, Bm, m by 1 order. Clear? Now A is m by n, x is n by 1, so m by 1 is this Ax, Ax equal to B. This is matrix form. This system of equation, it can be written in matrix form. Okay, matrix form. Matrix form. This is matrix form. Clear? Where coefficient matrix is this. X is x1, x2, x3, xn, solution matrix. Okay, and this is B and right hand side. In general, we can represent like this. Now, we know from the previous class that if here mn equations, number of equations m, number of unknown is n, if both are equal, then we can use for solving system of equations method of determinants, the Kramer rules. Kramer rules, by Kramer rules we can also solve. But for using Kramer's rule, there are different type of rules for solving this equation, Kramer rules. But for Kramer rules, Kramer's rule, for this we require m equals to n. For this we require m equals to n, means number of equation and number of unknowns. That is number of equations equals to number of unknowns. That is square matrix, it should be m equals to n. Then we can use Kramer rules. Second, universal method. And also in this case, the determinant and Also, determinant A is not equals to 0. Matrix inversion method. Matrix inversion method. For this, also we require m equals to n, and A is determinant A is not equals to 0, so that A inverse exists. For this also we require what? M equals to n, number of equation and number of unknowns, same, and determinant of the coefficient matrix is not 0. Then A inverse exists, and solution is given by A inverse B x equals to the solution matrix. The solution matrix. Solution matrix. Clear? So x can be found by using this, because determinant A equal to not 0, A inverse can be found, square matrix. Okay, so x equals to A inverse B, A inverse into B. You can multiply, then you can get the value of x, y, and z. This is the method of inversion method and Cramer's rules. These methods can be solved. These methods can be used for solving system of equations in case when number of equation and number of unknowns are equal. These methods are failed when number of equations and number of unknowns are different. If m equal to not n, then this method will fail. And also, if number of unknowns and a number of equations are more than 3, 4, 5, then for solving by using this method will be the very lengthy process. So, and also determinant should be not equals to 0, because if determinant equal to 0, number of equations or unknowns are equal, but determinants is equals to 0, then also this method will fail. So, by using rank of the matrix, we can solve system of equations. Okay, rank is very useful. Just in the previous class, we have already seen that how can we find the rank of a matrix. Rank of a matrix can be found by converting it to upper triangular matrix or echelon form. Number of non-zero rows is equals to the rank of the matrix. So rank is very useful for finding solution of this type of equations, where maybe number of equations, number of unknowns are different. Okay, so first of all, just Gauss third Gauss elimination method. Gauss-Jordan method. These two methods can also be used for finding solution of system of equation. Elimination method, just in this method we are converting coefficient matrix to echelon form. Coefficient matrix and totally we can take as a matrix form and we can convert it to the echelon form. Echelon form just like this. Suppose this system we are writing like this: A11, A12 up to A1n and A21, A22 up to A2n, and here AM1, AM2 up to AMn. This is coefficient matrix. Okay, so this is coefficient matrix A and this is x1, x2 up to xn. It can be written like this: B1, B2 up to Bn. This is in matrix notation. This system is matrix notation. Now, if we apply row operation to this system and we are trying to converting this as a echelon form, just operation, row operation we will use. Row operation, by using row operation we are trying to convert this matrix to echelon form. The operation we apply here and also will be applied here, not in this, only here and here. If we can convert this matrix by using row operation as a echelon form means we know, echelon form means just we are trying to make 0 here and first element should be 1, 1, 1, 1. This is our echelon form. So if by using row transformation we can convert this system such a way that the coefficient matrix will convert as a echelon form, then we can find solution by back substitution by using equivalent system, because there in this place, mostly in this place will be what? 0. Then this system will give simple form as for this equation only this is equals to some value, that is from here we can get the value of xn, from here we can value of xn minus 1, from here we can get the value of x2, x1, and finally we can get solution by converting echelon form by row operation. Just converting into echelon form. In this case, just we are eliminate unknowns from bottom level. 0, 0, 0, 0, 0, 0. The number of 0, the possible times we are trying to converting from bottom side 0. That means just we are eliminating unknowns from bottom side. And finally we can get just like echelon form. Here number. So equivalent system can be written and can be solved here by back substitution. And Gauss-Jordan method. Fourth method is Gauss-Jordan method. Gauss-Jordan method. In Gauss-Jordan method, fourth method, it can be also used. Gauss-Jordan method, just we are trying to eliminating unknowns from bottom level and also from top level, and we are trying to convert it in diagonal form. diagonal form. Just like here also 0 and 1, 1, 1. This type of. If we can convert in Jordan form, just we are trying to eliminate from bottom level and also from upper level, so that we can get a diagonal form matrix type, and then we can get solution directly. Back substitution is not required. We can get directly the value of the unknowns, because diagonal element are only just we can multiply and we can get first x1, then x2, then x3, then x4 is equals to, here converting value is the solution. This is the Gauss-Jordan method. Okay, so this type of first Kramer rules can be used for equal number of unknown as equations, and determinant is not equals to 0. Then Kramer rule, inverse rule also can be used. Elimination method by converting in echelon form. There is Gauss elimination method by converting Gauss-Jordan method, that is diagonal form. Okay, diagonal form. For this diagonal form, we can find solution of the system. And finally, we are having a rule for finding solutions using rank. Okay, so we will study about the solving system of equation by using rank here. So a system of equations may be homogeneous, may be not non-homogeneous equation. Non-homogeneous equation means right hand side are having some values, that is b is not 0. If b is 0 matrix, that is right hand side at 0, then we say homogeneous equation. For finding solution of non-zero non-homogeneous equation. Homogeneous equation means right hand side matrix, that is b will be 0 matrix, and non-homogeneous equation we are having formula related to rank. Okay, so here types of linear equation. Consistent, first, and second, inconsistent. System of equation is consistent. System of equation is inconsistent. What is the meaning of consistent and inconsistent? Consistent means system having some solution. System having some solution. Maybe unique solution, maybe infinite number of many solution. Means more than one solution may be possible. Okay, inconsistent means no solution. Inconsistent means no solution. Okay, so two types of equations. Inconsistent. Second, inconsistent. Inconsistent. No solution. Clear? Consistent means system have some solution. System have some solution. System have no solution. There is no solution for the system, and system have solution. Just like for this example, suppose we are having x plus 2y equals to 4 and 3x plus 6y equals to 5. This system have no solution. How? Just try to solve it. Multiply this by 3x, 3, then 3x plus 6y equals to 12. So here we see that equation 1, equation 2. So equation 1 into 3 minus equation 2 gives what? For solving, just try to solve it. So multiply by 3, 3x, 6y, 12. So just subtract it from here, then 0 plus 0 equals to 12 minus 5 equals to 7. That is 0 equals to 7. Not possible. So system have no solution. This system have no solution. So this type of system, this is 2 by 2. You can get also by 2 by 3, 4 by 6 and different type of equations, different number of equations, different number of unknowns may be there and the system may have no solution. For example, this. Okay. So, system types of linear equations. System of linear equations. Okay. Equation system. Consistent system have system of equations. Okay, this. Inconsistent will have no solution. Example. Now, consistent. If consistent, some solution means maybe unique solution, maybe infinite number of solutions, more than one solution. Okay, so here consider x plus 2y equals to 4 and 3x plus 2y equals to 3x plus 2y equals to 2. Clear? This. Just we can see that by solving this we can get a solution. Linear equation. So here just this minus this, so 2x, 2 minus 1, this is 1, this is 2, so 2 minus 1, what gives this minus this, 2x equals to minus 2, x equals to minus 1, x equals to minus 1, and x equal to minus 1, then y equals to x equal to minus 1, then y equals to 5 by 2, y equals to 5 by 2. So we can see that x equal to minus 1 here, minus 1 and plus 2 into 5 by 2 means 5 equals to 4, right? Similarly, this can be satisfied. X equal to minus 1, minus 3 plus 5 equals to 2, right? So this is unique solution. This is unique solution. Okay. So example for this unique solution. And suppose we are taking x plus 2y equals to 4 and 3x plus 2y equals to 12. In this case, just multiply it by 3 and subtract. So we can get 1 and 2. So 2 minus 3 into 1 gives what? 0 equals to 0. This is satisfied. So here we can get infinite number of solutions for this case. Infinite solution. Infinite solution. Infinite solution for this system. Infinite solution for this system. Unique solution. So consistent means system has some solution. Means unique solution, maybe unique solution, maybe infinite solution. More than one solution. Okay, so this is the meaning of consistent and inconsistent. Consistent means we can have unique solution or infinite number of solution. Inconsistent means have no solution. Okay, now we will discuss about rank method for solving any type of system of equations. That is, there may be the number of equations and number of unknowns are different. Okay, different number of unknowns and different number of equations may be there that can be solved by rank method. This is a very, very important use of rank of matrix for finding solution of system of equation. Okay, in the case where number of equations and number of unknowns are different, rank may be used for solving system of equation. Okay, so here for that we will make a matrix. For that, this is our system of equation. Suppose number of equations are n and number of unknowns are n. This is a matrix form. A is coefficient matrix, X is solution matrix, B is right hand side. This is non-homogeneous equation. They are the non-homogeneous equation. Okay, non-homogeneous. Non-homogeneous system of M equation in n unknowns. Non-homogeneous means right hand side are not equal 0. If we take right hand side as 0, then homogeneous equation. Okay, this is non-homogeneous equation. Now, for using rank to find the solution of this type of system, just we write first of all system of equation as a matrix form, where A is the coefficient matrix, X is the solution matrix, B is the right hand side matrix. Okay, and we prepare a new matrix. Suppose K is equals to matrix A, matrix B. That is coefficient matrix, and matrix B are writing it side by side. K, just let K. Then this is called augmented matrix. Let augmented matrix. Let K equal to this augmented matrix. K is called augmented matrix, and A is coefficient matrix. Just we consider coefficient matrix A and let K equal to this called augmented matrix. Okay, for solving this, just we will find rank of these two. This coefficient matrix is in this is also in the matrix K. Okay. Now, for finding solution, just first of all, what is the method? Or find the rank of. Find the rank of A and K. K is what? Augmented matrix. A coefficient matrix. K also includes A. Find the rank of this. Let rank A equals to R and rank of K equals to R dash. Okay. Then just find rank of A and rank of K also. By converting K to upper triangular form, we can find rank of A and K very easily from the upper triangular form by considering the number of non-zero rows. Okay. So just find rank both. Then what will be the result? Then according to Roche's theorem, then according to Roche's theorem. Okay. Then Roche's theorem. If R is equal to R dash, R equal to R dash, then system is consistent. If R equals to R dash, the rank of both, rank of A and K are equal, both rank equal, then system is consistent. And if R equal not R dash, then system is inconsistent. Inconsistent means no solution. If rank of these two are different, not equal, then inconsistent. No solution. If R equals to R dash, then system is consistent. Clear? So this is the Roche's theorem. When R equal to R dash, both rank are equal, then system consistent. And consistent, then just further test. If this rank is equals to number of unknowns, then unique solution. If this rank is less than number of unknowns, then infinite number of solutions. So here we can also discuss about this is augmented matrix and this is coefficient matrix. Okay. So for finding rank of augmented matrix and coefficient matrix, we have to convert augmented matrix to upper triangular form matrix. Then we can get rank easily by watching what? A number of non-zero rows. Okay, so here also if r equals to r dash is equals to n, number of unknowns, then system will have unique solution. If both rank equal and equals to n number of unknowns, then unique solution. And if r equals r dash is less than n number of unknowns, then less than n both rank equal and less than n number of unknowns, then infinite solution. System will have infinite number of solution. Clear? If rank is less than n, infinite number of solution. If rank is equal n, unique solution. In the case of consistent. So this is due to Rogers theorem. Okay. So our target is what? Finding rank. Rank of K equals to rank of A, B, where A is coefficient matrix, B is right side matrix in the matrix form. Okay, so just convert it to upper triangular form. Then you can get rank. Okay, so our target is what? Just write this matrix, augmented matrix, and convert it upper triangular form, and then write R and R dash, and just conclude like this. If both are equal, consistent. If equal number of unknowns, unique. If less than n, infinite. If not equal, inconsistent. Okay, so this is the technique for finding solution of a general non-homogeneous system of equation by using rank method. Okay, now just take some questions for understanding the rank method. Okay, now for non-homogeneous equation, means right hand side should not be 0 for non-homogeneous equation. Here we will take some questions. Always we have to write the system as a matrix equation where the value of x, value of b, value of coefficient matrix A we have to write first, and then make augmented matrix and convert it to echelon form, or upper triangular form matrix. Okay, and then by watching the number of non-zero rows in upper triangular form matrix, we can get rank, and then we can consider just like using Rogers theorem. Okay, so here consider 2x plus 6y equal to minus 11. 2x plus 6y equals to minus 11, and 6x 20y minus 6z. 6x plus 20y minus 6z equals to plus 20y minus 6z equal to minus 3, and 6y minus 18z, 6y minus 18z equals to minus 1. This system of equation, here how many number of unknowns? 3, x, y, z. Here z is not present, just we have to apply 0 coefficient to the z. Here 0 coefficient to the x. So make complete first equation, then you can write it as a matrix form. So here what? A will be coefficient matrix Ax equals to B. So A equals to what? We can write coefficient 2, 6 and 0. 2, 6, 0. And here 6, 20 minus 6. 6, 20 minus 6. Here 0, 6 minus 18. 0, 6 minus 18. And right hand side matrix minus 11, 3, minus 3, minus 1. Minus 11, 3, x equals to x, y, z. And b equals to what? Minus 11, minus 3, minus 1. This is the matrix notation. So, for determining whether this is consistent or not, whether following is consistent or not, just we have to write augmented matrix. Augmented matrix. What? K equals to just A and write B. That means what? A total 260, 260, 620 minus 6, 0, 6 minus 18, and B already B minus 11, minus 11, minus 3, minus 1. Yes, just like this. This is augmented matrix. Okay. From this augmented matrix, we have to find the rank of coefficient matrix. This is A, this is A, or this is B. And total is augmented matrix. Just now convert it to diagonal form. For converting it to diagonal form, okay, upper triangular form, just we can use this element, only row operation we have to apply. By using this, make it 0, and then by using this, make it 0. Okay, so here by converting, what we have to apply here for making it 0? R 2 minus 3R 1. Multiply by 3, but subtract from here. So this is equals to what? R2 to this. This is operation. So apply here. So 260 minus 11. We get minus 11. And here 0. 6 minus 6 0. So here 3. 18 minus 2. 20. 2. Here minus 6. Here minus multiply by 3. Minus 33. Subtracted from here 30 plus 33, and here 0, 6 minus 18 minus 1. Now by using this make it 0 also. So here we apply what? R3 to R3 minus 2 3 R2. Okay, minus 3 R2. Just use it because multiply it by 3 and subtract from here this. So we get what? 2 6 0 minus 11 0 2 minus 6 30. Here 0 0 minus 3 minus 18 minus plus 18 0. Also here in this minus 91 minus 91. Okay, minus 91. Now by using this we cannot completely make it 0 by any of the operation. So from here this is the part, in this part only this is for A. So here if we consider only this part, then rank of this number of non-zero rows 2. So rank of this is 2. But when we see the complete, the number of non-zero rows first, second, third 3. This part for A and complete part for K. Okay, so number of non-zero rows for A 2, number of non-zero rows for K 3. Okay, so we can write as number of non-zero rows we get rank A equals to 2, not equals to 3, rank K not equals to, because its rank is 2 and its total rank is 3. So not consistent. Not consistent. Not consistent. Not consistent. That is inconsistent. Inconsistent. R equal to not R dash. So by Rogers theorem, inconsistent. Not consistent is inconsistent. Okay. Similarly, now we will take one by one questions for solving system of equation here. Okay. So consider the questions where number of equation is greater than the number of unknowns. There is 3 unknowns are there and 4 equations are there. Okay. So for this questions we have to also make first augmented matrix. Here number of unknowns 3, number of equation 4. Test the consistency and hence solve following set of equation. Okay, so solution. Here we have matrix form as Ax equals to B, where A equals to what is the 4 equations are there, just see 4 equations are there here. Okay, 1 to 1, 1 3 4 2, 1 3 4 2. Just write coefficient matrix. And 2 1 minus 3 4, 2 1 minus 3 4, and then 1 minus 2 minus 1 2, 1 minus 2 minus 1 2 minus 1 2. So this is 4 by 3 because 4 equations are there, 3 unknowns A, and x is what? x1, x2, x3, and two 1 3 4. B is 2 1 3 4. This is B. Okay. In this system, coefficient matrix system can be written like this. Coefficient matrix is this. Solution matrix is unknowns, number of unknowns 3, and B is right hand matrix. This. We see that what is our target for testing? Augmented matrix. We say that the augmented matrix is K is equals to, what is augmented matrix? K equals to K A B. So K equals to, just write complete matrix 1 3 4 2 3 4 2 2 1 minus 3 4 1 minus 2 minus 1 2, and just write here B 2 1 3 4 2 1 3 4. This is augmented matrix. Now from this augmented matrix we can find the rank of A and K. Here A means this part, K means total. Just convert it to triangular form, upper triangular form. Okay, so here augmented matrix, just see, our target is what? By using row operation, just make here 0. By this one, we can make this 3 thing as 0. So this is equivalent means just apply operation here. Okay. So we can write here, this is equivalent to what operation here we apply? R 2 to R 2 minus, just by this 1 we can make it 0. So multiply by 3, 4, 2. So 3, 4, 2, R2 minus what? 3 R1, R3 minus 4 R1, R4 minus 2 R1. In short, we can write also it by what? R2, just like this, that is R2 1 minus 3. That means what? In short notation, just multiply the first row element by minus 3 and add to R2. So it can be written like this. Similarly, it can be written in short R3 1 minus 4, R4 1 minus 2. It can be written like this. So further we will use short notation. Okay. So here 1 2 1 2. This is 0 by multiplying 3. Here 0 3 means minus 6 minus 5 minus 2 minus 3 minus 5 minus 3 minus 6 minus 5. Okay, here 4 0 minus 8 minus 11 minus 4 minus 5 minus 8 minus 5 minus 8 plus this minus 5. Now this 2 0 minus 4 0 minus 2 0 minus 4 0. So we are getting this. Okay, by applying this operation. Now our target is what? Try. So making 0 here. So we can see that it can be convert to 1 1 1 1, and then by that 1 you can make it 0. Okay, so by this operation we get like this. Now further K is equivalent to this, and this is equivalent to new operation. Just what? Here R second minus 1 by 5. So by this operation we can see that 5 5 cancel, minus plus plus 1 1. 1 to 1 2, 1 2 1 2 and 0 1 1 1 and 0 minus 11 minus 5 minus 5, 0 minus 11 minus 5 minus 5 and 0 0 0 0. So this is the next. After this we can get like this. Okay. And further we can make it 0. We can make it 0. So also equivalent to what? 1 2 1 2. You can bifurcate this for finding rank. So here 0 1 1 1 0. Operation. What will be the operation? Just multiply it by 11 and add here. So R 3 2 11. So second row is multiplied by 11 and add to third row. So here 0 0 11 minus 5 6. Here also 6 0 0 0 0. This is the format. Now further it is impossible to make it 0, because if we make it 0 by using this, then there will be getting some number other than 0. So just this is the upper triangular matrix we can suppose, and from here we can find the rank of the matrix. The number of here rank of matrix is equals to number of non-zero rows. Here, since this, therefore, rank of coefficient matrix equals to 2, and rank of augmented matrix equals to also 2. Because when we see that in this part, so number of non-zero rows is 3. Sorry, 3. Because in this part number of non-zero rows is 3. In total number of non-zero is also 3. So rank of A is 3, rank of total K is 3. This is the equivalent matrix of K. That is, equivalent system are written from here. This system can be written, equivalent system can be written from here. Okay. Now, since rank are equal and since R equals to rank A equal R dash rank K, implies R equal R dash equal 3 equal number of unknowns. Both rank are equal. So the R dash, rank of A, rank of K, both are equal 3. Number of unknowns are 3. Number of unknowns 3. Which implies that system will have a unique solution, unique solution, unique solution, and the equivalent system is given by, equivalent system is given by using this. Okay, this is converted to this, and this is right hand side here. Equivalent system is given by what? First matrix 1 to 1, 2 1, 0 1 1, 0 0 6, 0 0 0. This is equivalent system. Here x1, x2, x3 is equals to 2160. 2160. This is equivalent system. And from here we can write equations. Implies we can write, multiply this by this. So x1 plus 2, x2 plus x3 equals to 2. Now this is multiplied to here. x2 plus x3, x2 plus x3 equals to 1. And this is multiplied to here, 6. So 6x3 equals to 6x3 equals to 6. So this is equivalent system. Now it can be solved. Simple. x3 equals to 1. x3 equals to 1. Now this x3 can be used here. So x2 equals to 0. So x2 equals to 0. And this x3 and x2 can be used here. This is 0, this is 1. So x1 equals to 1. So x1 equals to 1. So 1 0 1 is the solution. Okay. 1 0 1 is the solution. x2 0, x1 1, x3 1. So 1 0 1 is solution. This is 1 0 1. Which are unique solution. Clear? 1 0 1. So here the system of equation consists unknowns 3 and number of equations 4. So for different number of unknowns and number of equations, you can use rank method. So first of all, just make augmented matrix and find the both rank of coefficient matrix and augmented matrix. If both are equal, then consistent, and if equal to number of unknowns, unique solution. If not, is less than number of unknowns, then infinite solution. So take another question here, just for consistency and solve. Okay, so here also just main thing is just you have to convert augmented matrix to upper triangular form matrix so that you can find rank easily. Okay. Infinite number of solution means there will be some unknowns arbitrary with arbitrary values, independent unknowns. Okay. So here 5, 3, 7, 4. 5, 3, 7. Just what? See the question here. We have matrix form for this system. Ax equals to b. Okay. Here we have Ax equals to b, where A equals to 5, 3, 7. Okay, 5, 3, 7, 5, 3, 7, 3, 26, 2. 3, 26, 2 and 7 to 10. 7 to 10. And x equals to xyz. Number of unknown 3. Number of unknown 3 here. And 495. 495. That is b equals to 495. That is here the square matrix will be the coefficient matrix. Okay, because 3 by 3. So 3 unknowns, 3 equations. Augmented matrix is K equals to AB implies K equals to, just write one by one, this 5, 3, 7, 3, 26, 2, 7, 2, 10, 495, 495. Okay. Now we have to convert it in upper triangular form. So for this, just see, augment target is what? By using this element, make it 0. See here, this is not 1, so just convert it 1 by applying 1, 3 by 5, 7 by 5 and 4 by 5 and 3, 26, 2, 9, 7, 2, 10, 5. For making it 1, just we divide, that means this R 1, 1 by 5. First row is multiplied by 1 by 5. Now, by using this 1, we can make this to 0. So what operation? R2 1 minus 3. R3 1 minus 7. Just we can do like this. Okay. Now here, first row will be 1, 3 by 5, 7 by 5, 4 by 5. Clear? First row is this. Now first row is multiplied by 3 and here 0. So 1 is 0 and minus 9 by 5. 26 minus 9 by 5 121 by 5. Just multiply it by minus 3 and add to here minus 3. minus 20, 21 by 5, minus 21 by 5 means minus 21 plus 10 minus 11 by 5. Here minus 12 by 5. So minus, what will be the value? Here 9 minus by 12 by 5, 45 minus 12, 3, 3, 33 by 5, 33 by 5 plus 33 by 5. Here also 121 by this and 10 minus 11 by 5. So 11 by 5, 31 by 5. So all are positive value. Minus 11 by 5. So here minus 11 by 5. Because minus 21 and 10 minus 11 by 5. Okay. This. Now minus 7. Multiply to here and make it 0. Minus 21 by 5. 21 by 5. Again minus 11 by 5. Minus 11 by 5. Just calculate it. 1 by 5 minus 3 by 5. Okay? This. By using this operation, we get like this. Now our main target is what? Converting it to echelon form or upper triangular form. So this to 0. Now make it also 0 by using this. So here we see that if we divide it by 11 and add here, then 0. By 11 and add here by 0. Then 11 by add here 0. So after this line, k is equivalent to, this k is equivalent to, by operation what? R 3, 2, 1 by 11. Second row is multiplied by 1 by 11. So 11 by 5 added to here 0, 0, 0. So we get first 1, 3 by 5, 7 by 5 and 4 by 5. Here 0, 121 by 5, minus 11 by 5 and 33 by 5. And this 0, 0, 0, 0. Just we get like this. Now, here we can see that it can be simplified like this. Now, multiply by 5, then 1374 and multiply by 5 by 11. It can be written as a simplified form R1 multiplied by 5 and R2 multiplied by 5 by 11. So we can get 5, 3, 7, 4, 0, 11, minus 1, 3, 0, 0, 0, 0. So this is our simplified form of upper triangular matrix. Here, from here we can find rank of A. This is A, total is K. Number of non-zero rank rows is equals to rank of matrix. Therefore, rank of A equals to R equals to 2 and rank of K equals to R dash equals to 2. Both rank are 2. Number of non-zero is 2. So 2. This is 0 rows. Both rank are equal. That's consistent. But less than number of unknowns. Here number of unknown is 3. So infinite number of solutions. In case infinite number of solutions, so there will be arbitrary values will assign to number of unknowns. Just see, since R equals to R dash equals to 2 and less than 3 number of unknowns. Number of unknowns. Less than number of unknowns. Therefore, system will have finite number of solution. System will have infinite number of solutions in which n minus r, that is 3 minus 2 equals to 1 unknown will be arbitrary. That is independent. Independent, that means may take any value. That is arbitrary. Now, equivalent system is equivalent system means from here we can write equivalent system 5x from here we can write equivalent system. This is A, x, y, z. So 5x 3y 7 z, 5x 3y 7 z equals to 4. Second equation, 11 minus 1. So 11 y minus z equals to 3. Only this two. And remaining is 0. So this is equivalent system. So one unknown will be arbitrary, independent. So let z equals to k. Arbitrary numbers. K arbitrary numbers. Okay, arbitrary numbers. Z equal to k. So this system here 11y minus z equals to 3 implies 11y minus k z equals to k. K is arbitrary number, so k equals to 3. So here y equals to k by 11 plus 3 by 11. y equals to k by 11 plus 3 by 11. Okay, so this is the value of y in terms of k, in terms of k, and this is the value of z. So value of z, value of y. Also, just put the value of z and y in 1, this equation. So also 5x plus 3y k by 11 3 by 11 k by 11 plus 3 by 11 plus 7k equals to 4. Now solving it, we can write x equals to here, just transferring right hand side and solving, you can get the value as minus 16 by 11k, minus 16 by 11k plus 7 by 11, 7 by 11. So this is the value of x. So x in terms of k, arbitrary, z in terms of k, arbitrary, y in terms of k, arbitrary. So thus we get infinitely many solution as x equals to minus 16 by 11k plus 7 by 11, y equals to k by 11 plus 3 by 11, and z equals to k. Where k is arbitrary. Where k is arbitrary numbers. Okay, so infinitely many solutions. You can get a number to k, once solution you can get particular. K equal to 1, then you can get a solution. K equal to 2, then you can get a solution. The infinitely many solutions of the system. Okay, now there is a very important questions. So for what values of lambda and mu, the system of linear equation, given equation, unique solution, no solution, infinite solution, and I also find the solution for lambda equal to 2 and lambda equal to mu equal to 8 is here given. So this type of questions is also important. Just we have to find the value of, discuss about the value of lambda and mu for which the system will have infinitely many solution, unique solution, no solution. Okay, so just same method here. First of all, we have to write augmented matrix and convert it to upper triangular form, but there will be the value lambda and mu. So just for finding rank of coefficient matrix and augmented matrix, we will discuss about different value of lambda and mu. For that, what will be the rank of a and k, and on the basis of that we can say that when for which values of lambda and mu the system will have no solution, infinite solution and unique solution. Okay. So here the given system is 111, 125, 23 lambda. So given system can be written as given system can be written as 1 1 1 1 2 5. Two, 3 lambda, and here x, y, z. Here number of unknown is also 3, and right hand matrix is given what? 6, 10, mu. 6, 10 and mu. Here lambda and mu are both constant. So for this is coefficient matrix, this is solution matrix, this is right hand matrix. That is Ax equals to B. That is Ax equals to B. Now augmented matrix, just our target is what? Finding the value of lambda and mu. For which value of lambda and mu system will have first what? A unique solution, no solution, and finite solution. Okay. So we have augmented matrix. We have augmented matrix K B. K equals to 1 1 1 6 1 2 5 10 2 3 lambda mu. Just K is equivalent to make 0 this and this by using first. So here we can use R2 1 minus 1, R3 1 minus 2. Just multiply it by minus 1 and adding to here. Multiply it by minus 2 and adding to third. So we can get 1 1 1 6. Here 0, here 1, here 4 and minus 6 4, and here 0 1, just minus 2 1 minus 2, so lambda minus 2, and here mu minus 12, and once again just make it 0. So equivalent to system 1 1 1 6 0 1 4 4 0 0, that is operation R 3 2 minus 1. So this is 0, this is 0, then minus 1 minus 1 minus 6, so lambda minus 6 and mu minus 16. This is we get. Clear. Now from this upper triangular or this matrix, okay, K is equivalent to this. K is equivalent to this. K is equivalent to this. So in this matrix, for no solution, first for unique solution. Now for first for unique solution. For unique solution, rank of this equals to rank of total. For unique solution, rank of A is equals to rank of K equals to 3 equals to number of unknowns. That is, here we require lambda minus 2 equals to naught, lambda minus 6 equals to naught, 0. Mu may be any value. Lambda minus 6, this is not equals to 0, and mu may any value, maybe 0, may not be 0. So this is not 0. So number of non-zero rows will be 3. And this is, if this is 0, also number of non-zero row is 3. If not 0, also number of non-zero row is 3. So mu may take any value. So this is implies lambda equals to lambda equal not 6, and mu may take any value for unique solution. Okay, second, for no solution. For no solution. For no solution means rank of these two are different. So if we take this is 0 and this is not 0, then rank of this is will be 2 and total rank 3. So for no solution, rank of A is not equals to rank of K. Rank of K. That is, here we require for not equal rank. So this is equal 0, this is not equal 0. So lambda minus 6 is not equal 0, is equal 0, sorry, is equal 0, and mu minus 16 is equal, not equal 0. Implies lambda equals 6 and mu equal not 16. Okay? For no solution. This. If we take this type of value, then both rank will be different. This rank will be 2 and this rank will be 3. Okay. So this is the value of lambda and mu for no solution. This is the value of lambda and mu for unique solution. Now for infinitely many solution. Now for infinitely many solution, we see that here what we require. Third, infinitely for infinitely many solutions. For infinitely many solutions. What we require? Rank of this is less than number of unknowns 3, that is 2. For 2, this is 0, this is 0. Rank of A is equal, rank of K is equals to, is less than 3 number of unknowns. That is, here we require what? Lambda minus 6 equals to 0 and mu minus 16 equals to 0. Implies lambda equals to 6 and mu equals to 16. For infinitely many solution, lambda equal to 6 and mu equal to 16, infinite solution. 6 and 16. 6 and 16. Okay. So this type of discussion you can give for no solution, infinitely many solution and unique solution. Okay. Now, finally we have to find the solution for lambda equals to 2 and mu equals to 8. Now, if we take lambda equals to 2 and mu equals to 8, mu equals to 8, lambda 2 mu 8, then equivalent system is equivalent system. We can write equivalent system from here, but lambda equals to 2 and mu equals to 8. Then equivalent system is from here 1 1 1 1 0 1 4 1 1 1 0 1 4. Here 0 0 2 minus 6 lambda 2 mu 8. Here x y z equivalent system 6 4 6 4 8 minus 16. So here we see that 1 1 1 0 1 4 0 0 minus 4 x y z equals to 6 4 minus 8. Now we can write equivalence equation. Here x plus y plus z equals to 6 by multiplying, and y plus 4z equals to 4, and minus 4z equals to minus 8. So this can be solved. Z equals to what? 2. Z equals to 2. Z equals to 2. Z equals to 2. Then 8. Y equals to 4 minus 8 minus 4. Y equals to minus 4. Y equals to minus 4. Now y equals to minus 4 and z equals to 2. Y equals to minus 4, z equals to 2. Minus 4 plus 2. Minus 2. 8. X equal to 8. X equals to 8. Thus, solution is given by x equals to 8, y equals to -4 and z equals to 2. 8 minus 4, 2. 8 minus 4, 2. Clear? So this is the solution. Okay, for lambda equal to 2 and mu equals to 8. Now, homogeneous system of equation. Okay, homogeneous system of equation means right hand side having 0. So just like system of homogeneous equation. System of homogeneous equation. Suppose a11 x1, a12 x2 up to a1n xn equals to right hand side 0. Similarly, a21 x2, a22 x2 up to 2n xn. N unknowns, number of equations 1 to up to, we can take a m equation. x1, this is 1, x1 a m2 x2 a mn constant are there equals to 0. This is mn equations. Right hand side matrix B in place of B, 0 matrix. So it can be written as A x equals to 0 matrix form, homogeneous equation, where A equals to A11, A12, A1n, AM1, M2, AMN. This coefficient matrix. Okay, MN. Coefficient matrix. Clear? And x equals to x1, x2 up to xn. Solution matrix. Solution matrix. And O is 0 matrix. And this is zero matrix. This is m by 1. This is n by 1. This is m by n. This is system of homogeneous equation. Okay. Here this system of equations are satisfied if we put x1, x2, x3 and xn equals to 0. Any constants may be there, all the equation will be satisfied because right hand side is 0. Since x1, x2, x3, xn equals to 0, will satisfy x1, x2, x3, xn, all values are 0, will satisfy the system Ax equals to O. This is Ax equals to O. This will satisfy the system Ax equal to 0 matrix. Therefore, these values are the solution of system, that is zero solution, also called trivial solution, that is trivial solution. Clear? Which implies that homogeneous system of equation is always consistent. Always consistent, because there is solution, zero solution, the non-trivial solution always exists. So, system is always consistent. But this trivial solution, zero solution, so our main target is finding non-trivial solution. That is, all values of x, y, z, x1, x2, x3, n are not 0. Okay. So, here, just like in the Rorschach's theorem, we can discuss about constant coefficient matrix or augmented matrix here. Coefficient matrix is A, m by n matrix, order matrix. Okay. So, here, first of all, always consistent. Okay. Always consistent and may have either zero solution, trivial solution, or non-trivial solution, non-trivial solution, that is non-zero solution, Here, non-zero solution. Now, zero solution always exists, and non-trivial solution, non-zero solution, that is, some of the values are not 0 of x1, x2, x3. So, for non-zero solution, we can find the condition by using Rauch's theorem. For that, augmented matrix K is equals to A O, because right hand side B, in place of B, 0 matrix, that is matrix A112, A1n, A212, 2n, AM12, AMN. And 0 matrix. This is augmented matrix. And according to Rauch's theorem, if coefficient of augmented matrix and coefficient matrix, that is this, are equal, then system is consistent. Here, since this line, this column having all 0, so always rank of this is equal to the rank of K. That is, system is always consistent. Okay, so that's why system is consistent. Here, always rank A is equals to rank K, implies system always consistent. Always consistent. For non-trivial solution, means rank of A and rank of K both are equal and less than the number of unknowns. Here, number of unknowns, m unknowns. Number of unknowns is n and number of equations is mn. Okay. So for non-trivial solution, rank of this and rank of K, rank A is equals to rank K is less than n number of unknowns. Clear? Here number of unknowns is n and both rank are equal and less than n. So that will depend on the value of mn. Okay? If m equals to n, then if m less than n, m is what? Number of equation is less than n, is less than number of unknowns, then its rank, m is less than n, then its rank always will be less than n, because here number of rows are m rows, m is less than n, so number of non-zero rows is equals to the rank. So here m is less than n, so rank will be less than n, If m less than n, then system will have non-trivial infinitely many solution. Infinitely many solution. Non-trivial solution means infinitely many solution. Infinitely many solutions. Because whenever we get non-trivial solution, then we can have infinitely many solutions. Because one set of values x1, x1, x2, x1, x2, x3, xn satisfies these equations, then we can multiply this set, that will also satisfy this, because right hand side is 0. So there are infinitely many solutions. So for non-trivial solution means infinitely many solutions. So if m less than n, then system will have non-trivial infinitely many solutions. If, and second thing, if m equals to n, then this matrix will be a square matrix. So for non-trivial solution, that is infinitely many solution, rank of this should be less than number of unknowns. So rank of this, if m equals to n, then n by n is square matrix, then n by n is square matrix. So determinant of this nth order matrix should be equals to 0, because then rank will be less than n. Okay. And if rank determinant is equals to non-zero, then rank will be equals to number of unknowns. Number of unknowns means n. In that case, only 0 solution we can get. For infinitely many solution, just rank of this is less than n, that's why determinant should be 0. And if rank of this is equals to n, then we will get only trivial solution. Okay, so here, if m equals to n, then system Ax equals to O, m equals to n, then the system Ax equals to O will have only trivial solution if determinant A equals to not 0, that is rank of A is equals to n, number of unknowns. Clear? If m equals to n, the number of equations and number of unknowns are equal, then matrix will be a square matrix, so we can find determinant. Determinant is equals to not 0, then rank is equals to n, number of unknowns, mn, both are equal. unknowns. Okay, only trivial solution we will get. We'll have only trivial solution. Trivial solution means zero solution. Okay. And for non-trivial solution, determinant A should be equals to 0. Determinant A should be 0. That is, determinant A is equals to 0. Determinant A equals to 0, then non-trivial solution. For non-trivial solution, determinant A should be 0. That is, determinant equals to 0. In this case, the rank of rank of A is less than n, number of unknowns. Clear? In this case, rank A is less than n, number of unknowns. Non-trivial solution, rank is less than n. And trivial solution, rank determinant is equals to not 0. This is for testing whether the homogeneous system of equation having trivial solution or non-trivial solution. For non-trivial solution, determinant equals to 0. Clear? This rank is less than n. Okay. And for trivial solution, determinant equals to not 0. That is, rank is equals to number of unknowns. Okay. So remember this. On the basis of this, now we have to solve some questions. Okay. So here, take a question, that is, solve the equation. The given questions, see. So first of all, here we see that rank of A and rank of augmented matrix in the case of homogeneous system of equation are always same, so always consistent. So for finding rank of both augmented matrix and coefficient matrix, just we require only finding the rank of coefficient matrix. Okay, only find the rank of coefficient matrix. So for finding coefficient matrix, just we have to reduce coefficient matrix to a upper triangular matrix. So first system is given. Solve the equations. So here the coefficient matrix 1 to 3, 3, 4, 4. Solution. Coefficient matrix of system is A 1, 2, 3, 3, 4, 4. Okay. 7, 10, 12. 7, 10, 12. This is coefficient matrix. Now just we will try to reduce it in the upper triangular form matrix so that we can find its rank very easily by row operations. That is most of the element just here from the bottom. We are trying to convert it at 0. So here first element is 1, so we can apply operation R 2 1 minus 3, R 3 1 minus 7. That is, first row is multiplied by minus 3 and added to second, and so on. This is the 1 2 3 and minus 3. So this is 0. Minus 6. Minus 6 plus 4. Minus 2. Minus 6 plus 4. Minus 2. Minus 9 plus 4. Minus 5. And here 0. Minus 14. Plus 10. Minus 4. Minus 21 plus 12 minus 9. Okay, so this is the operation. Now again try to convert it 0 by this. So 1 2 3 0 minus 2 minus 5, and this is multiplied by 2 and subtracted. This is multiplied by, if we take like this operation, 3 second minus 2. That is, minus 2 is multiplied to here 4 is added to here 0. So 0 0, and here minus plus 10 is added to here 1. Just we get this. Now this 1 cannot be converted to 0. So here this is the upper triangular matrix. So rank of A is equals to number of non-zero rows equals to rank A equals to 3. 3 is number of unknowns. Here number of unknowns is 3. So number of unknowns. Number of unknowns. Number of rank is equals to number of unknowns. That is, implies system will have only trivial solution. Trivial solution, that is zero solution, as x equals to y equals to z equals to 0. So this is solution. Clear? So first set of equation, system of equation will have only zero solution, because rank is equals to number of unknowns. Now second question, second, having here question second, coefficient matrix is what? A equals to the C in the second set of equation. Second set of equation having 4 unknowns, equation 3. So 4 2 1 3, 4 2 1 3, and 6 3 4 7, 6 3 4 7, and 2 1 0 1, 2 1 0 1. Missing term is multiplied by coefficient 0. So this is the coefficient matrix. Now just try to convert it in echelon form or upper triangular form. Okay, so this is By this 4, we will convert this and this as 0. So for that, R21 minus 3 by 2, R31 minus 1 by 2. So we can see that if this is multiplied by minus 12 by 2 minus 6, this is added. So 4, 2, 1, 3 is 0. Minus 2 to cancel, minus 3, 3. This is also 0. And 1 minus 3 by 2. This is multiplied to here, minus 3 by 2. So minus 3 by 2. 4 minus 3 by 2. Minus 3 by 2 added to 4. So 8 minus 3, 5 by 2. So this is 5 by 2. Also here minus 9. 14 minus 9, 5 by 2. Also here 5 by 2. Clear? And second, minus half, this is 0. Minus half is minus 1 plus 0. Here minus half is minus half. This is also minus half. Just you can see. Minus 3 by 2 plus 1. This minus half. So we get like this. Now once again we can apply operation here. By this we can make it 0. 4, 2, 1, 3, 0, 0, 5 by 2, 5 by 2 and this 0, 0, 0, 0. By using operation what? R3, 2, 1 by 5. Just multiplied by 1 by 5, 5, 5 cancel. So minus half, minus 5, 5 cancel, minus half. Not minus half, plus half, sorry, plus half. Here plus half and minus half, 0. This is the upper triangular matrix. 3 by 4. Number of non-zero rows, 2. Here rank A is equals to 2 number of non-zero rows. Okay, number of non-zero rows, and rank is less than, this is less than 4 number of unknowns, number of unknowns, less than, rank is less than, 2 is less than 4. Therefore non-trivial solution. Implies system will have non-trivial, infinite, solutions. Non-trivial, infinite solutions. In which, because infinite solution, that means some of the variables will be arbitrary. So we can find that in which this non-trivial infinite solution, in which non-trivial infinite solution, in which n minus r equals to 4 minus 2 equals to 2 unknowns are independent. That is, will be independent. That is, two unknowns will be arbitrary. Any arbitrary values. Say here for finding solution, equivalent equations are okay. Here equivalent equations are what? From this last equivalent matrix. Here equivalent solutions of 4 unknowns. Equations are, how can we write? Just equivalent matrix 4 2 1 3 0 0 5 by 2 5 by 2 0 0 0 0 and x y z w. These are the 4 unknowns. Okay, this is 3 by 4, this is 4 by 1, so equals to 3 by 1. That is this 0 0 0. This equation can be written as 4x plus 2y plus z plus 3w equals to 0 and 5 by 2 z plus 5 by 2 w equals to 0. Okay. So from here we can find infinitely many solutions, as two unknowns will take any arbitrary values. So here give x equals to k1, okay, w equals to k2, then z equals to minus k2. x1 suppose k1 arbitrary numbers, w suppose k2, because out of these 4 unknowns 2 are arbitrary. So suppose x1 and w are arbitrary. Now if w is arbitrary, that is suppose k2, then from here z equals to minus w, so z equals to minus k2. So x1 is this, x2 is this, omega is this, z is this. Now y can be find. So here y equals to, here y equals to, so z equals to minus k 2. So here minus k2, w k2, this is k2, so minus k2 plus 3k2, 2k2. So 2 2 and this is 4. So 2 2 cancel, 4 2x. So y equals to minus 2x minus k2 minus 2 k1 minus K2. Okay, where which are infinitely many solution. Where K1, K2, K1, K2 are arbitrary okay. So this is our solution. Okay, so here y equals to minus 2x minus 2k1 minus k2. Okay, now x k1 w k2 z minus k2. Okay, z equals to minus k2. So this is the technique for finding infinitely many solution, because here you can give k1 k2 any arbitrary value. This is 1, this is 2, then you can get the value of z and y. Similarly, infinitely many solution you can get. So this is the solution of this homogeneous equation. Now take on more questions. That is determine the value of b such that the system of homogeneous equation has non-trivial solution. Find the trivial solution by matrix method and trivial solution. So here the given system is, take another questions for solving. In these questions, in the equation there is given a constant b. We have to find the value of b so that the system will have non-trivial solution, and we have to find that solution. That is, non-trivial solution means infinitely many solution, and for trivial solution, what will be the value of b? Trivial means zero solution. Okay, so here same process, just we have to find the upper triangular form or echelon form of the coefficient matrix by applying row operations. Okay, by using number of non-zero rows as a rank, we can find the rank of coefficient matrix. So here 1 2x y plus 2z. So given system is 2x plus y plus 2z equals to 0. X plus y plus 3z equals to 0, and another 4 3 bz equals to 0. 4x 3y plus b z equals to 0. This is the system of equation. Okay, here b 4 3 and b. Okay, so this is the system. Here b is the constant. We have to find the value of b, for which value of b system is having non-trivial solution, trivial solution. Coefficient matrix. Coefficient matrix is A equals to 2 1 2 1 1 3 4 3 b. Here b is constant. We have to find the value of b, for which system will have non-trivial solution. So here, for finding upper triangular matrix, just apply the operation. What first? Just we can interchange, because if there here we can convert 1, then by 1 we can convert lower element as 0. So first of all 1 2. 1 2 means first row and second row are interchanged. 1 1 3 and 2 1 3 4 3 B. Okay, and now apply another operation. What? R 2 1 minus 2, R 3 1 minus 4. 1 is, this is multiplied by minus 2. So minus 2 plus here 0. So 1 1 3. Okay, 1 1 3 is 0. Now this is multiplied by minus 2. So minus 2 plus 1 minus 1. Minus 6 plus this. Minus 6 plus 3 minus 3. And here minus 4 here 0. Minus 4 plus 3 minus 1. Minus 12. So B minus 12. This. Okay. Now once again we apply operation for converting this 0, that is this is subtracted from this. This is minus 1. Multiply here minus 1 and add it here. So A is equivalent to one more operation 1 1 3 R 3 2 minus 1. Second row is multiplied by minus 1. So 0 1 3 is added to here. So 0 minus 1 minus 3 0 0 minus 1 is plus 3. This was a 2 value 2 2 1 2 2 1 2. So here minus 4. So here minus 4. Okay, there was mistake in writing, like minus 4. Now minus 4 plus 4 is added here, B minus 8. So B minus 8. B minus 8. Now this is V. So from here we can decide what will be the value of B. Clear? What will be the value of B here? B minus 8. This is B minus 8. B minus 8. Now we can see that for non-trivial solution, here number of unknown is 3. So rank should be less than 3. For rank should less than 3, so that is rank must be 2. For that, number of non-zero rows should be 2. So for that this will be 0. From here it is clear that for trivial solution, that is rank of A should be less than 3, number of unknowns that is here we require B minus 8 equals to 0. Rank of A is less than 3. That is B minus 8 equals to 0. Implies B equals to 8. Then rank A is equals to 2 is less than 3. So for non-trivial infinitely many solution, B is equals to 8. Okay, B equals to 8. First. Okay, now for trivial solution, non and non-trivial solution is given by equivalent equations as what? Equivalent equation can be written from here. 1, 1, 3, 0, minus 1, minus 4, 0, 0, 8 minus 8. This, because in place of B we have to use B equals to 8 for non-trivial solution. Okay, and here number of unknown is 3, right side 0, so we can solve it. Okay, so what? X plus y plus 3z equals to 0 and minus y minus 4 z equals to 0, and this is 0, this is 0. So this is the system. Here rank is here n minus r, that is 3 minus 2 equals to 1. Unknown will be arbitrary. Let z equals to k1. Then let z equals to k1. Then from here y equals to minus 4 k1, y equals to minus 4z equals to minus 4 k1. So y is minus 4 k1, z is k1, and x equals to minus y minus 3z, minus y minus 3z, minus of minus 4 k1 y, and z k1 minus 3 k1. So this is equals to what? We can see that minus plus 4 k1 minus 3 k1 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 k1. Okay, k1. Hence, required non-trivial infinite many solution is given by x equals to k1, y equals to minus 4 k1, and z equals to k1. k1. X equals to k1 and y equals to minus 4 k1, z equals to k1. Where k1 is any arbitrary number. Okay, so this is solution. Clear? So non-trivial solution by matrix method. Now for trivial solution, that means rank should be equals to 3. For that b minus n is not equals to 0. So we can say here second, for trivial solution, rank should be equals to 3. That is, here we require b minus 8 is not equals to 0. That is, b is not equals to 8. Then rank of A equals to 3. Number of unknowns. So for trivial solution, b is not equals to 8. So for trivial solution, b is not equals to 8. Okay. So this is the solution of these questions by using homogeneous system of equations. Now take on more questions. Okay, here find the value of lambda for which the equation are consistent. Homogeneous equation, consistent means determinant equals to 0. So the given equation will be consistent if determinant of coefficient matrix is equals to 0. So here we can write the given system will be consistent if coefficient matrix, determinant of coefficient matrix equals to 0. Determinant of coefficient matrix is 0, will be consistent. The given system will be consistent if determinant of coefficient matrix is equals to 0. That is, here determinant of coefficient matrix just lambda minus 1 Just write lambda minus 1, 3 lambda plus 1, 3 lambda plus 1, 2 lambda is equals to 0. Okay, lambda minus 1, also 4 lambda minus 2, 4 lambda minus 2, 3 lambda plus 3, lambda plus 3, and 2 3 lambda plus 1, 2 3 lambda plus 1, and one more 3 lambda minus 1, 3 lambda minus 1, like this. Okay, so this is coefficient matrix. Determinant of coefficient matrix equals to 0. System will be consistent if this is equal to 0. Now solve it or find value of lambda. Okay, so here determinant we can also apply R2 minus R1 by R2 minus R1. So here lambda minus 1, 3 lambda plus 1, 2 lambda, this is 0, just this minus this 0. Here determinant can be also solved by property. Okay na? So 0 and lambda minus 3, 3 minus lambda, lambda minus 3, 3 minus lambda, just subtract from there this. Okay, and 2, 3 lambda plus 1, 3 lambda minus 1. Also apply column operation by C3 plus C2. We can apply C3 plus C2. So lambda minus 1, 0, 2, 3 lambda plus 1, lambda minus 3, 3 lambda plus 1. Here this plus this, 5 lambda plus 1. Now 0, and here 3 3 6 lambda minus 2, 6 lambda minus 2, this is equals to 0 by this operation, column operation. You can use it here. Okay, so see here that from this determinant, by applying in the determinant, but just we have to solve and find the value of lambda. Here in this row, lambda minus 3 can be taken common, and lambda minus 1, 3 lambda plus 1, 5 lambda plus 1, and 0, 1, 0, and 2, 3 lambda plus 1, and 2 lambda, 2, 3 lambda plus 3 lambda minus 1. Just we can write this, and after solving we can get lambda equals to 0 or 3. Lambda equal to 0 or 3. Okay, lambda equal to 0 or 3. Just you can solve it. Lambda minus 3. Now expand this determinant along this. So this into this minus this into this. So lambda equals to 0 or 3. Now smallest value. Okay, smallest value of this what? 0. Now for lambda equals to 0, now first when lambda equals to 0, smallest, lambda equals to 0, the equation will be lambda equals to 0. Just in the given equation, take lambda equals to 0. Then the system will be minus x plus y equal to 0, minus x plus y equals to 0. See in the equation, okay, minus x minus 2y plus 3z, minus x minus 2y plus 3z equals to 0, and also 2x plus y minus 3z. 2x plus y minus 3z equals to 0. 2x plus y minus 3z equals to 0. So this two, the given system is reduced to this when lambda equals to 0. Okay. Equation 1, equation 2, equation 3. This equation can be solved by matrix method also, but here solving second and third by cross multiplication method. Multiplication method, we get x upon what? 6 minus 3, y upon 6 minus 3, and z upon minus 1 plus 4, implies x equal y equal z. So ratio is this. Okay, first. And when second is when lambda equals to 3, when equations will be identical, that is 2 tan 6, 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 x, y, z, 0, 0. X, Y, Z, 0, 0. When lambda equals to 3 in the given system will be like this. Okay. So it can be solved very simple. What? By applying row operation. Just subtract this from this implies 2 tan 6, 0, 0, 0, 0, 0, 0, and x, y, z equals to 0, 0, 0 by R2 minus R1, R3 minus R1. R2 and 3 is subtracted by R1. So implies 2x plus 10y plus 6z equals to 0. Implies x equals to what? K1, y equals to K2, and z equals to, here you can solve it, z equals to what? Minus K1 by 3 minus 5 K2 by 3. Minus K1 by 3 minus 5 K2 by 3. Why K1, K2 are arbitrary? Because here rank is 1. Since n equals to 3, r equals to 1, implies n minus r equals to 3 minus 1 equals to 2. Unknown are arbitrary. Say x equals to k1, y equals to k2. Okay, so this is solution. Rank is 1, so n minus r, 3 minus 1, 2. Two unknowns are arbitrary. So say x equal to k1, y equals to k2. So you can put here. So z equals to this. So this is the solution. Okay, solution. which is solution. Okay. Okay, now I will give some questions for your practice assignment work. Okay, so do these questions, very important questions. Just use Rogers theorem, that is in case of non-homogeneous equation, find the augmented rank of augmented matrix and coefficient matrix both. If they are equal, then consistent, then C, equal rank is less than A, whether less than or equal. If equal to unknowns, then unique solution. Is less than, then infinitely many solution. If rank are not equal, then inconsistent. Less than n, then infinitely many solution you can find. What is the rank? N minus r, that is equal to independent solution. Independent unknowns, that is arbitrary. So give arbitrary values to 1 or 2 unknowns and solve system, equivalent system. Then you can get solution. Okay. So similarly, homogeneous equation. For homogeneous equation, only use coefficient matrix. Find the rank. If rank is equals to number of unknowns, only trivial solution. Trivial solution means 0 solution. And for non-trivial solution, rank should be less than number of unknowns. So solve these questions. Okay, important questions, and do more and more practice for solving system of equations. Okay.